A major incentive for adopting cloud solutions such as Azure is to enable IT departments to move server resources to the cloud. This can save money and also simplify operations by removing the need to maintain expensive data centers, and that will need UPS generators, fail-safe mechanisms, clustered database servers, and the list will go endless. For small and medium-sized companies which might not have the expertise to maintain their own robust infrastructure, moving to the cloud is particularly appealing. Once the resources are moved to Azure, they require the same networking functionality as on-premise deployment. And in specific scenarios, they require some level of network isolation, for example, creating DMZs. Azure Networking components offer a range of functionalities and services that help organizations design and build cloud infrastructure services that meet their requirements. Azure has several networking components. Having a knowledge of network and its underlying components is very important, even if you are managing networks in the cloud. As you know by now, you can create several resources in Azure, for example, storage accounts, virtual machines, databases, etc. But where do they eventually sit? They will eventually sit on a virtual network. A virtual network is a boundary in which your resources will be placed. A virtual network in Azure is called as VNet. A VNet is a representation of your own network in the cloud. You can use VNets to provision and manage virtual private networks in Azure. You can also connect your on-premise infrastructure with this VNet. So the connection between on-premise networks and the virtual networks in Azure can be kept private. Optionally, you can also have a VNet to VNet communication. Each VNet you create has its own CIDR block. CIDR blocks are referred in RFC 1918. To simplify CIDR blocks, they are categorized as Class A, B, C, D, and E. You will usually use private networks to create a CIDR block or create a VNet. So Azure Virtual Networks, called as VNets, is nothing but a representation of your own network in the cloud. This is created to make sure that you can host your resources privately in an isolated Azure cloud network. In this lab, we will go ahead and create a virtual network in Azure subscription. In the virtual network, we will create two subnets. And thereafter, in each subnet, we will be hosting two virtual machines. The communication between each of the virtual machines will then be established with security groups. Let's get started. I am currently logged into my subscription and I'm using a pay-as-you-go subscription, but if you are doing the labs along with me, you may have to create a free tier account for yourself. To create a virtual network, I will click on virtual networks right here, and then this will navigate to me a section where I can create virtual networks. I can either click on the add button or create virtual network. And this will take me to a blade where I have to fill up the options like the name of the virtual network, address space, subscription, etc. I'll quickly fill these up. The name of the production as VNet underscore production. I can use a class C or class B or class A address space. Make sure that you research on what is RFC 1918. Basically, it states that IP addresses are classified as class A, B, C, D, and E, and it also talks about private addresses and public addresses. I will use a class C address /16, which will give me about 65,000 IP addresses, which is a very big range. You can choose a subscription as pay as you go, or if you're using a free subscription, you will see free trial in this drop down menu. Make sure you have a resource group.
I will create a new resource group as I do not have it. Say payroll and say OK. Select a region and then a subnet name as well. Just call it as subnet 1. And the address space must be within this address space and not outside it. So I'll select 192.168.30.0/24. I'll leave the rest of the default settings and click on Create. It will take a minute to fully create a virtual network in Azure. Now that my virtual network vnet_production is ready, I'll click on it and then create another subnet. When we were creating the virtual network, we created a single subnet. But then to create another subnet, you have to click on the subnet section and then click on the plus subnet button. As you notice, there is a subnet 1 which is already available because this was created during the VNet creation. I will click on this button to create a second subnet. I'll call this as subnet 2 and the CIDR block will be 192.168.40.0/24. I'll leave the rest of the options default and click on OK. It will take a minute to create the second subnet in the existing virtual network. Now that the subnet is created, we are now ready to host virtual machines in each of the subnets. So when we are creating virtual machines, we must make sure that we are pointing it to the following vnet_production virtual network, and then in each of the subnets, we will be hosting virtual machine each. Let's go ahead and create virtual machines. To create a virtual machine, I need to click on this virtual machine option on the left hand side and then click on this add button. This will give me a blade or a form that will let me fill up the options like the virtual machine name, the resource group, etc. Let's start by selecting the resource group. We already have a resource group with the name payroll, so I'll select that. The virtual machine name, let's call it as web server 1, and then we'll select the region. So I need to select the same region where I have the virtual network, which is the central US. At this time, I do not need any redundancy. I'll leave the image as Windows Server 2012 Data Center. Okay, 2 CPUs and 8 gigs is actually a lot for our test environment. So let's go ahead and change the size. I'll change the size to not the lowest available because I'm looking at performance as well. I think 2 CPUs and 4 GB of RAM is good for now. I'll select the username as root_admin and make sure that I will give it a strong password. So looks like my characters are accepted. Inbound ports, I need to have 3389 allowed because this is a Windows based machine. I need to do RDP to this machine, so I will have port number 3389 or RDP selected. If I would have selected Linux machine here in the drop down menu, then I had to select SSH because Windows does not listen on 22 and Linux doesn't listen on 3389, right? So you need to select appropriate ports. Yeah, I do not have a Windows license, so I'll select no. Choose the hard disks carefully here because by default it points to premium SSD, which is of course going to give you a lot of performance, but then also is expensive. So I will choose a standard hard disk in this case because I'm not looking for great performance, but anything that lets me do this lab is fair enough, and standard SSD is good for that. I'll select next to select the networking options. Remember, we created a virtual network few minutes ago. So I will select vnet_production because this is the only network available in our region. We created 2 subnets. So we have subnet 1 and subnet 2 in the drop-down menu. This is web server 1 and hence I will select subnet 1. When we create web server 2, I will be selecting subnet 2 in the drop-down menu. I will leave these options as default because that's what I want. I wanted to have a public IP address so that I can RDP from my network. I also want inbound ports to be RDP so that it will allow incoming connections on 3389. I'm not doing a load balancer lab at this time, so I'll select no. Under the management section, I will leave these options as default and click on advanced. All these options are also something that I do not want at this time, so next and then create. It will review the settings, look at all the settings one after another, and then make sure that it validates and checks to see if these settings and parameters are right. And if everything is correct, it will say validation has passed. I'll click on create. My virtual machine deployment is underway, it's in progress, and it will take like 4 to 7 minutes to create Windows-based virtual machines. For Linux machines, it is very quick and not more than 2 minutes for a regular Ubuntu or a CentOS virtual machine. So once the VM is created, we will RDP to it, connect to it, and then we'll progress with creating a second virtual machine. Okay, looks like our virtual machine deployment is complete. I'll click on Go to Resource to go to the virtual machine and then capture its public IP. On the right hand side, I'll see the public IP address of the virtual machine. I'll copy this and then go to the MSTSC or Microsoft Terminal Services console. There, I can copy and paste the public IP address and then click on Connect. This should prompt me to type the user ID and password. Should not take more than a minute to get connected and show us the desktop. So our Windows Server 2012 R2 machine is ready. Let's go ahead and create another virtual machine, Web Server 2, in the second subnet, which is subnet 2 in the same VNet, which is VNet-production. To do so, I'll minimize this RDP and go to the virtual machines, and I will follow the same exact procedure to create a second web server. The resource group will be same. The name of the virtual machine will be Web Server 2. Make sure we select the same region and select a Windows machine here. Change the size to something acceptable, which is 2 CPUs and 4 gigs of memory. Type the username and confirm the password. And I'll make sure that I'm allowing RDP here. I'll leave rest of the options as default. And let's click on next. I have to wait in the networking section to make sure that the virtual network selected is right and the subnet selected is subnet 2. I'll just click on next, next, leave these options as default and quickly create the second web server 2. We will again run through the validation. Once the validation is complete, click on create. I'll now pause the video and start again once the virtual machine deployment is completed. The virtual machine is now created. I'll click on Go to Resource to go to the virtual machine. And just like what we did previous time, I'll launch the MSTSC, which is also called as Microsoft Terminal Services Console or the remote desktop connection. I'll copy its IP address and paste it here so that that will take me to this new web server that we just created. Should be quick to connect to the second virtual machine because we have given enough CPUs and memories to it, and there is no application running on it, so there's no overhead on the virtual machine, so performance must be good. So now what we have is a set of 2 virtual machines running on 2 different subnets in the same VNet. The objective is to connect these 2 virtual machines and make sure that they are reachable. The first thing that we have to do is open the firewalls on the virtual machines, so at least we can have some kind of connectivity there. Right now, these 2 virtual machines are totally isolated. Now that both the virtual machines are created and we were also able to RDP to this virtual machines, I will go ahead and keep them side by side so that we can test and verify the connectivity. So this on the left hand side is my web server 1 and this is web server 2. Just type hostname to verify. Yeah, this is web server 1 and this is web server 2. I can just type ipconfig on each of these machines to identify their IP addresses. So if you notice, their IP addresses are in this range, which is 192.168.30. This was the CIDR block of the subnet 1, and hence it got an IP address in that range. If you look at the second virtual machine, you will see the IP address in the range of what's assigned to subnet 2, which is 192.168.40.0.4. Let's see if we can ping these two virtual machines. Say ping 192.168.web server 2's IP address, which is 192.168.40.4. Yes, we are able to ping it. Let's also try to do it from the second machine, which is 192.168.30.4 from here. .30.4. Enter. So that means that the communication is well established between these two virtual machines. Let's see how this is happening. Now I'm going to go back to the Azure console and look at the networking section. In the networking section, although we have explicitly opened only 3389 from anywhere, look at the second rule, which says allow VNet inbound on any port, on any protocol from any virtual network. So communication between the virtual machines is already there. It's there by default. Okay. So you can click on this particular network security group and see what the default options are. I'm going to click on inbound security rules. And the first one, as we know, is the one that we created, but the rest of them are default. If you click on this little icon here, which says default rules, it will not show you the default rules. So this one is explicitly created. But if I click on this default rule option, it will show me what the default rules are. That means by default, the virtual machines will be able to talk to each other just because of this rule. At times, even after having this particular rule in place, the virtual machines may not be able to talk to each other because Windows has an inbuilt firewall. So you may have to allow a rule on the inbuilt Windows firewall, or specifically for ping connections, you have to allow ICMP. In this lab, we created a virtual network with two subnets, and then we created two virtual machines in each subnet. We also saw how the communication happens between the two web servers, or we can say any resources. So even if we would have created a database in the second subnet, the communication will happen based on the rules in the security group. Security group act just like the firewall on your premise, so you can allow inbound connections or outbound connections in the security groups.
Let's go ahead and run a PowerShell script to create a virtual network. We'll also create few subnets using PowerShell. In the previous video, we created the virtual network and subnet using the graphical user interface. But as you know, everything that's done through the graphical user interface can be scripted, can be provisioned using a PowerShell script. Let's learn how to create a PowerShell script and provision resources, specifically in this case, a virtual network in Azure subscription. The command to create a virtual network is new-az virtual network. Right now, there are thousands and thousands of commandlets which Azure has. It is not technically possible to memorize all of these commandlets in your memory because you create storage, you restart virtual machines, you create and provision virtual machines. You do so many activities in Azure with PowerShell, it becomes difficult to remember them, to memorize them, and to recollect them at the right time. Microsoft has given us a weapon in PowerShell, get-command. Get-command is a commandlet to search for the command in Azure's database and all the modules that are there on your computer. So let's say you want to get a command that starts with a string or that has the word called network in that commandlet, right? So all you have to do is just put network or your string in your quotes in wildcard, and this will search for this particular string in all the commandlets in Azure in your repository or in your modules. So when you execute this, it should show me all the commandlets like that. So every commandlet that is there on the screen has the term network inside it. For example, this one, it has update -Azure RM storage account network rule set. So this is just an example, but every commandlet that you will see in this list will have the string called network in it. Similarly, let's say you want to create a new network. In that case, I will prefix it with new. So this will show me all the commands that start with the word new and has this string called network in it, right? Let's execute that. Well, there are so many of these. As you see here, there are some of them which are pointing to EC2, which is AWS specific command. So like I said, it is searching for all the modules, and I have AWS modules as well on my computer. So if I want to filter it and narrow down to a particular module, you can just type -module and then the module name like Azure or AWS or whatever. But in this case, my focus is just to get the commandlet, which is new-Azure RM virtual network. That is a commandlet to create a new virtual network. Now, we do not use Azure RM anymore. We just use AZ like this. So yeah, you can definitely create virtual network with new-Azure RM virtual network, but it's preferred to use the latest commandlets, which is new-AZ virtual network. You can of course look at the version numbers here on the right side, which is 1.1.3, 1.13.0. Well, let's go start using this commandlet. So I'll get rid of this, but always practice this get-command, and you will use it when, let's say, you're not able to recollect a particular commandlet. That's when you will use this form or method of getting your favorite command. Let's get rid of this now, and that's the command new-AZ virtual network. Okay, and then the name of the virtual network, let's call it as, let's call it some random name, alpha beta. And then the resource group in which it should be created is tech IT department. Yeah, and the location in East US. And then I would also need an address prefix for this network. Let's say the address prefix is, I'll put that in a class A network this time, because when I was creating a network using the graphical user interface, it was a class C, 192.168.00/16. This one I want to create in a class A, so it will be 10.0, maybe 10.20.0.0/16, close the quotes. Okay, and I will make sure that I put inside a variable. Looks like my insert is on. I'll put inside a variable called new vnet equals, yeah, and now let's execute this and see what happens. It should create a vnet, and the attributes of those vnet are stored inside a variable called new vnet. The reason why I've stored it inside a variable is so that I can use this variable moving forward when creating subnets. Right, looks like it is created. And what's inside $vnet? $new vnet. Okay, well, that's that. I've got a new vnet called alpha beta, and its title block is 10.20.0.0/16. Let's create a subnet now with a command called add-az virtual network subnet configuration. That's the command. But like I said, you do not have to ever memorize this. You can always use get-command to search for the commandlet you're looking for. Okay, so the name of my subnet will be, let's call it as private subnet or private underscore subnet. And this will be created inside my virtual network. The values of my virtual network are stored inside the variable called new vnet, and that has an address prefix of 10.20.30.0/24. This will be the address prefix of my new subnet. Hyphen. Well, what else do we need to create a new subnet? We have the virtual network name given private subnet, address prefix, and I think that's all. So let's also put this inside a variable called new subnet, right? And then execute that. Okay, looks like that is created as well. So you can retrieve the values of the new subnet and identify whether it is created or not by running this command called get-az virtual network subnet config, and I want to get the values of my new subnet which I want to create. It is private underscore subnet, and this is inside my virtual network called $new vnet. All right, let's execute that now. Okay, looks like that's that. Now you need to associate the subnet to the vnet. The way you do that is by getting the values of the subnet and then saying, hey, set these attributes by running this command set-az virtual network. You need to set the values of the subnet into the Azure virtual network, and then you execute. You need to set the values of the subnet into the Azure virtual network, and then you execute this. Looks like that's done. Let's go to the graphical user interface and verify if the creation of the subnet and VNet is there or not. So I'll go back to my portal and click on virtual networks, refresh this page. I must have a new VNet there. Okay, it looks like our VNet called alpha beta is created. Let's go and verify if we have subnets there. There you go, our subnet called private underscore subnet is created. Similarly, you can create the second subnet inside it as well. In the previous lectures, we learned and understood how you can create virtual networks. We also created subnets, but what are they? Let's learn about the importance of subnets. A virtual network can be segmented into one or more subnets. A subnet or subnetwork provides logical divisions within your network. Subnets will help us improve the security, increase performance, and also make it easier to manage the network. Each subnet contains a range of IP addresses that fall within the virtual network address space. Each subnet must have a unique address range, which we mentioned as a CIDR block. The address range cannot overlap with other subnets in the virtual network, and that means that other subnets cannot have the same CIDR block or overlapping CIDR block in that virtual network in the same subscription. It is very important to carefully plan your subnets. Azure routes network traffic between all subnets in a virtual network by default, and we saw that in one of the videos earlier where we had the demonstration of rules in the security group. However, you can also override Azure's default routing to prevent Azure routing between subnets or to route traffic between subnets through a network virtual appliance. Always remember that Azure will reserve the first three IP addresses and the last IP address in each subnet address range. That means if you are doing a capacity planning and then having a CIDR block of /24, out of these 256 IP addresses, 5 of them are reserved. That means you can only use 251 IP addresses and assign them to your resources in the subnet. It is important to note that you can have multiple network interface cards assigned to your virtual machine in Azure. For certain business requirements, you may want to have multiple network cards attached to the same VM. So you can create virtual machines in Azure and attach multiple NICs to each of your VMs. Having multiple NICs is a requirement for many network virtual appliances, such as think about application delivery or WAN optimization solutions. So having multiple NICs also provides more network traffic management functionality, including isolation of traffic between the front-end NIC and the back-end NIC, or separation of data traffic from the management traffic. And this list could be just going on, but the idea is to have two different network cards for two different business purposes. Let's go ahead and see how you can attach multiple network cards to the same VM. In this demonstration, we will have one network card getting an IP address from one subnet and another network card getting IP address from a different subnet in the same VNet. So right now we've got a network called business NW1, and there are two subnets called subnet 1 and subnet 2. Their CIDR blocks are represented as 10.20.30/24, and the subnet 2 is 10.20.40.0/24. I have a virtual machine created in subnet 1. So if you look at this web server, it is created in a virtual network which I just showed, which is business NW1, and it is in subnet 1. Let's go look at the networking statistics. Well, it has a network interface which is there in subnet 1. And as per the discussion, we did say that we can have multiple network cards. And for demonstration purposes, let's go ahead and create the second network card in the second subnet, which is subnet 2. To create and attach a network card, I need to just click on this button, which is Add Network Interface. But keep in mind that in order to attach a network interface to my virtual machine, the VM must be in shutdown mode. Otherwise, I'll get an error message. Let's see how the error message looks like. Let's attempt to attach the network interface to the virtual machine, and if we get the error message, we'll see, because I'm sure we have to shut down the virtual machine, without which we'll not be able to attach it to the VM. Okay, so I'll click on attach network interface and then create a new network interface. The name of the network interface can be just anything. I'll call it as public network card, and this will then go into a second subnet. You can choose between dynamic IP or a static IP. If you click on static IP, you can type in one IP address from this range. I will leave it as dynamic at this time and click on create. It is creating a new network interface and should take like 2 to 3 minutes based on my experience to create a new network interface. I'll pause the video for a minute and then resume once it is ready. Looks like the network interface is created. Let's go ahead and try to attach it now. So I'll click on attach network interface one more time, and in the drop down menu we now have our newly created public network card. I'll click on OK and see what happens. Now we got an error message on the top right hand side which says that the virtual machine must be stopped and deallocated before it can be updated to have multiple network interfaces and vice versa. So attaching a new network card needs downtime. If you have any change management schedules, make sure that you follow the change management procedures, and the cab must approve the change. That's when you shut it down and attach the network card. Now because this is a test server and we do not have any change procedures, I'll just click on stop and let it get deallocated. Once it is stopped, I'll go back to the same place and then click on networking and attach a network interface. And since shutting down will take some time, I'll pause the video again and resume once it is ready. Now that the VM is stopped and deallocated, as we see in the status here, we can now go to the networking section and see if we can add the new network interface to this virtual machine. To do so, I'll click on the attach network interface button and then make sure that I have my network interface in this drop down menu. Well, that's the only one I have at this time, but in production you may have a lot more than this. So make sure that you're selecting the right network card and then I click on OK, and then wait for a few minutes to have the network interface attached to my VM. Looks like the network interface is attached, and that's why we see two network cards now. One is web server 826, which has the IP address of 10.20.30.4, which is picked up from subnet 1. Remember that the subnet 1 had the CIDR block of 10.20.30.0/24, whereas the second one, which is the public network interface card, now this has an IP address of 10.20.40.4. So the second network card has got an IP from the subnet 2, which had a CIDR block of 10.20.40.0/24. So it is possible to have two network cards attached to the same VM, and then those two network cards have the IP addresses getting from two different subnets in the same network. We know the fact that if two devices needs to talk to each other, they need IP addresses, and you assign IP addresses to the resources. In Azure, it is no different. So you can assign IP addresses to Azure resources to communicate with other Azure resources. And that could be your on-premise network or the internet. So there are two types of IP addresses that we're talking about. In your virtual network, when you have an Azure resource, you can contain both public and private IP addresses. The private IP addresses are used for communication within the Azure virtual network. So if there are virtual machines and databases in your virtual network that need to talk to each other, they will use a private IP. You will also use a private IP address if you have extended your network and connected your on-premise infrastructure with your VNet. So you will use private IP addresses for communication with the resources in your VNet to the resources in your premise. To connect your on-premise network to Azure network, you will need something called as a VPN gateway or express route. And these are used to extend your network to Azure. Public IP addresses, on the other hand, are used for communication with the internet, as the name says, public. So if there is any public facing entity or public facing endpoint, then you will need a public IP address assigned to your virtual machine or the Azure resource. IP addresses can either have a static assignment or a dynamic assignment. Static IP addresses do not change and are best for certain scenarios such as DNS name resolution, where a change in IP address would require updating host records. It's also good for IP address based security models, which requires apps or services to have a static IP address. SSL certificates are always linked to an IP address. Firewall rules that allow or deny traffic based on IP address ranges. Role-based virtual machines such as domain controllers and DNS servers. So critical servers will always have a static assignment of IP address. As a best practice, you may decide to separate dynamic assignment with static assignment. Organizations usually have a dynamic assignment into a particular subnet, and a static assignment goes to a different subnet. So all the devices that have a dynamic IP address will go into one subnet. All the devices that have static IP addresses will go into a separate subnet. And IP addresses are never managed from within a virtual machine. Remember this, please. If you want to change the IP address assignment from static to dynamic, never go to the network card properties and change that radio button. Let's never do that, because there have been several scenarios where this mechanism of changing static to dynamic is not supported. If you would ever like to do it, you always do it from the Azure portal or PowerShell. So remember that IP address management is not done from within the virtual machine. It is done from the Azure portal. A private IP address can be associated with a virtual machine, an internal load balancer, and application gateway as well. Azure can provide an IP address to your resource using dynamic assignment or static assignment. Dynamic assignment is when Azure automatically assigns the next available unassigned or unreserved IP address in the subnet's address range. For example, Azure will assign 10.0.0.10 to a new resource if the addresses 10.0.0.4 to 9 are already assigned to other resources. Dynamic allocation is the default method of allocation. Static, on the other hand, is where you select and assign any unassigned or unreserved IP address in the subnet's address range. For example, if the subnet's address range is 10.0.0.0/16 and addresses 10.0.0.4 to 10.0.0.9 are already assigned to other resources, you can assign any address between 10.0.0.10 to 10.0.255.254. In the next video, let's go ahead and see how you can manage the IP addresses associated with a virtual machine network interface card, internet-facing load balancers, VPN gateways, and application gateways. If you choose dynamic assignment, then Azure will provide you with an IP address. You can also assign the IP address statically, and that then would be a static assignment. The type of resource affects the assignment. So depending on whether it's a virtual machine, load balancer, VPN gateway, or an application gateway, your options to select dynamic or static will be limited. In case of each of these options, you have the dynamic assignment option. But if you have a VPN gateway or an application gateway, you cannot set a static IP address to these two resources. If I have to create a public IP address, I'll just click on the search box and type public IP address and then select public IP address from the drop down menu. And then as you see, I've got a couple of these public IP addresses assigned to the virtual machines that we have created during the lab. But let's go create a new one. I'll click on this add and we'll get a blade to create a public IP. You have the options to select between IPv4, IPv6 or both. And then what's important to understand is the SKUs. You have the option of basic and standard. Let's understand these. So when you select a basic SKU, you have the option for either static or dynamic. But with standard, you can only have a static IP address assignment. With basic, you have open security by default, but with standard, you get better security options. That means that you are secure by default and any inbound traffic is closed. You can assign a basic SKU to all virtual machines with their network interfaces, VPN gateways, application gateways, and internet-facing load balancers. With standard SKUs, they can only be assigned to network interfaces, which is virtual machines, or public standard load balancers. Basic SKUs are not zone redundant by default, but standard SKUs are zone redundant by default. That means if something happens to your network interface, then the traffic will be routed to a different zone. That's what makes it zone redundant. And that's the default behavior for standard SKUs. I'll choose basic at this time and then give it a name. Just call it a web server. And then you have the option of choosing a dynamic IP address allocation or a static. I'll leave it to dynamic at this time. You can also select idle timeout minutes. This is the number of minutes it will keep a session alive. In DNS name label, I should type a unique name that's not assigned to any other public IP address in this subscription or outside this subscription. So if I type public web server, it will then be validated and then looks like this is not assigned to any other web server. Subscription, I'll leave it the way it is and put it in my resource group in East US and then finally click on create. So I have a public IP address of dynamic IP address assignment. As you see, it is getting deployed at this time. It'll take a minute to show up on the public IP address interface. Okay, as you see that the web server public IP address is created, I'll click on it and then you can assign it to either a virtual machine or to a load balancer. Let's click on associate button and see what happens. Now in the drop-down menu, you have the options to select either a load balancer or a network interface, right? So when I click on network interface, it will show all the network interfaces in East US region. The one that is connected to my virtual machine is public network card. I can just click on it and say OK. So now this web server public IP address is associated to my network interface, which is then connected to my virtual machine. There you go. On the right hand side, you have the virtual machine name as well, to which it is associated. Once you are done with your work, you can always disassociate it and just click on yes. That means that this web server public IP address is getting detached from the network card. So this network card called public network card will not have this IP address anymore. Once you're done with your lab, make sure that you go ahead and delete it just by clicking on delete and yes. In the next lab, we'll see how do you create a private IP address and attach it to your network interfaces. Address that we added to the virtual machine. So you will be learning few PowerShell commands to manage the network interface. So here's my virtual machine called web server. It has an IP address of 10.20.30.4. It also has a public IP address. Now, if I would like to get information about this VM, then well, you can just go to the graphical user interface or just spin up your PowerShell ISC and run few commands to get this information. It's always recommended that you use PowerShell to get that information because it's just about scripting it once and you keep the script ready so that you can run it time and again when you need the information, like getting an IP address. I have the PowerShell ISC here, and let's go ahead and run few commands. So the command to get a network interface information will be get-az network interface, and then I'll just do a tab completion to see if it automatically completes, and it does. Now let's assume that we got a lot of virtual machines. In production environment, you will have more than one. And that also means that you will have lots of network interfaces. So if I just run this command, it should retrieve all the network interfaces that are there in my subscription. So if I run this, I should get list of all the network cards that I have. There you go. So we got the information about the IP addresses, the virtual machine to which it is assigned to, whether it is assigned to a load balancer or an application gateway, whether it's static or dynamic. Well, you have all that information. I can pipe it to retrieve just the names of the network card, and when you run that, you will not get all this information, and then you will get just the names of the network cards, which will be looking pretty decent on the screen instead of looking, all garbage information. Probably that's something that you don't want to see. Well, yeah, with this, you just see the names and not all the information or the metadata of the network card. Now, the network card in which we are interested in is Web Server 826 because this is the network card that is attached to my machine. Now, if I flip back to the graphical user interface and go to the networking section of my web server, I'll see that the network interface is Web Server 826. It has a private IP address of 10.20.30.4 and also has a public IP address of 13.82.103.143. In your case, it may be different. Now, let's try to retrieve this information using PowerShell. So I'll go back to PowerShell ISC and point my PowerShell script to Web Server 826. That means that I will use specific syntaxes like name equals Web Server 826, and then I also say that it is in a resource group name called, I think it is IT Tech, yeah, Tech IT Department. Just copy that and paste it. Now if I run it, it will not give me information about all the network cards in my subscription. It will give me information only about Web Server 826. So let's run it to see what is the metadata of the network interface called Web Server 826. So this is what I have. I'll scroll up to the top to start from the beginning. The name is Web Server 826 in a resource group called as Tech IT Department. It is in a provisioning state called succeeded. Let's scroll down further to see other attributes of our interest. Okay, so the private IP address is 1020. Oops. Okay, scrolling up to the top again. Okay, the private IP address is 10.20.30.4. Yes, it has a dynamic allocation method used. And then, is it assigned to a virtual machine or a network card? It's not assigned to a load balancer for sure because this value is empty. It is using an IPv4. It is not assigned to an application gateway, so the value is empty. Right, so I'm able to get all this information about the network card called web server 826. Now, how do we get just the IP address of this machine? Because there's a lot of metadata inside this and I only want to see the IP address. So what I'm going to do is put the information inside a variable. So I'll call it as $nick equals get hyphen da 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 whatever. So when I execute this, I will have the output of this command stored inside $nick variable. So if I just type $nick here, I will get the same output as you see on the screen. Yeah. Now you can use $nick and see what are the variables stored inside the $nick variable. To see that, I will use a dot and then it will automatically populate all the attributes that are stored inside $nick. You should look for the information that you are interested in. For example, IP configurations. So I'll select that and then execute just this part to see what happens. Now I've got specific information, so I will flip it. I will flip the screen to keep a side-by-side interface so that I can see things in a better view. So $nick.ip configuration has this information. The specific information that I am looking for is the private address field, which is 10.20.30.4. So I can put a dot here, which is $nick.ip configuration dot private IP address, and then you will get this output. Let's see how that goes. So I will copy this and then make enough space for myself here and then say dot. Okay, so we got certain attributes. I'll just copy this and paste there and see what happens. Now let's execute line 2. What do we have? See this output 10.30.4, 10.20.30.4 is the private IP address of this device. Now let's say you also want to know whether it is statically allocated or dynamically allocated. What is the attribute? The attribute is private IP address allocation method, which is dynamic. Now if you want to get that information, well, you know what to do. Well, just copy this part and paste it, and then the information that you are looking for is this. Well, just jumping around. Okay, private IP address method is this. So copy and paste it here. I'll flip the screen like this so that you can see it better. So $nick.ip configurations dot private IP address is giving me the IP address, but dot private IP allocation method is giving me whether it's dynamic or static. As you see, you really do not have to memorize anything. It's all right here in PowerShell. Now, if I execute line 2 and 3, it will give me the IP address as an output and dynamic also as an output, right? You can also frame it in a better way by putting these inside a variable again and say $IP address equals that and $allocation method equals that, right? So now just run all of that and the IP address will be stored inside this variable. The allocation method, dynamic or static, is stored inside this variable. So now we can write that $information equals what? The IP address of the device is what? The IP address of the device is $IP address. Okay, now I just have to put an concatenation, which is a plus right here, right? And then I have to put a concatenation plus here again. All right, and the allocation, oops, typo, allocation method is what? Dollar all method. Okay, move to the right a little bit, put a colon so it looks better on the output, plus dollar all method, right? So this is all hard coded in the output. I'll execute this line number 5 to see how it looks. Alright, there you go. So now if I just say dollar, oops, dollar info, okay, and now execute the whole thing, you'll get the output as the IP address of the device is whatever the IP is, and the allocation method is whatever method it is, dynamic or static. So as you see on the screen, we got the output like this. The IP address of the device is 10.20.30.4 and the allocation method is dynamic. Well, you can be as much creative as possible. You can send it out as an export to a CSV, update into a database, whatever you want to do. But this is the skeleton of writing a small script. Let's go ahead and remove the IP address or deallocate it from the machine. Now let's go ahead and make some changes to the network card. I want to change this dynamic allocation to static allocation. As you see in the output, the allocation method is dynamic. Let's go ahead and change this to static. So what I'm going to do is go to this particular part here, which is line number 3, okay, and copy this and take it to line number 4. And then I say that $nick.ipconfigurations.private IP allocation method is equals to, well, dynamic. Okay, so I'm enforcing this and saying that instead of, well, it's already dynamic, so it's not dynamic, it's static, right? So this is what I want to change it to. So $nick.ipconfigurations.private IP allocation method is static, and then I will set it to the network card. To do so, I will say set hyphen az network interface. Okay, that picked up with auto tab completion. Set hyphen az network interface hyphen with the name network interface, which is $nick. So I've got all the $nick information inside the $nick variable, right? Because the $nick is a variable that has all the information about network card called web server 826. So if I say set hyphen is a network interface with this information, okay, let's go ahead and execute this and see what happens. Okay, so I'll just execute line number 4 and 5, and then once it is done, I will run line number 7. Yeah, okay, let's run line number 4 and 5. There you go. As you see, there's one small change that I made here. I added an array. So by adding this little thing here, I just mean to say that if the virtual machine has multiple network cards, then just look at the first one. Don't look at the other network cards, because there's only one network card that I want to modify. So the first one starts with 0, the second one starts with 1, the third one will start with 2, right? So yeah, so this execution is completed, and the address allocation must now be changed to static. There you go. Private IP address allocation method is static. Okay, so let's try to get certain information again, just like this. The IP address of this device is 10.0.0.4 or whatever, and the allocation method is, this time it must be static. Okay, so let's do that again. $all method equals that, and this time I will comment line number 4 and line number 5, because I don't want to set anything, I want to get the information. So let the script go and get the information about my virtual network card, and then get the IP address, IP allocation method, put this in a variable called $info, and show it up on the screen, right? Let's run that all the way from line number 1 through line number 9. So this time the output must be a little bit different. The only difference is that $all method is not dynamic but static at this time, because we have used a commandlet called set-az network interface to edit the properties of the network interface. Well, script is running, it will take some time, but feel free to modify this script in your test environment. You can go ahead and take it and run it as it is, but also see how you can export it to a CSV file, export it to a text file, Administrators also dump this information into a CMDB constantly to update the database. Well, there you go. We got some information. The IP address is 10.20.30.4 and the allocation method is static, right? So earlier we got dynamic, but now this time we got static. So in this video, we learned how you can retrieve the information from Azure, specifically the network card information. We saw how you can see all the network cards, polling a particular network card, retrieving the IP address attribute, IP allocation method attribute, and not just retrieving, but also editing the attributes of the network card. Azure Service Endpoints allows us to connect certain PaaS offerings from our virtual networks in Azure. This means that our Azure virtual machines can interact with Azure SQL and storage accounts as if they are part of the same virtual network, rather than our Azure virtual machines accessing them over public endpoint. With the help of service endpoints, the traffic switches to use virtual network's private IP address as the source IP addresses when accessing the Azure service from a virtual network. This switch allows you to access the services without the need for any reserved or public IP addresses used in the IP firewalls. In the next video, let's learn about why we should be using service endpoints. So we now know that the service endpoints are used to connect your virtual machines to platform as a service based services in Azure. Let's understand why service endpoints must be utilized in corporate enterprise environments. The first point is improved security for your Azure service resources. VNet's private address space can be overlapping, and so it cannot be used to uniquely identify traffic originating from your VNet. Service endpoints provide the ability to secure Azure service resources to your virtual network by extending VNet identity to the service. Once service endpoints are enabled in your virtual network, you can secure Azure service resources to your virtual network by adding a virtual network rule to the resources. Optimal routing for Azure service traffic from your virtual network. Today, any routes in your virtual network that force internet traffic to your premises or your virtual appliances, known as force tunneling, also force Azure service traffic to take the same route as the internet traffic. Service endpoints provide optimal routing for the Azure traffic. Endpoints always take service traffic directly from your virtual network to the service on the Microsoft Azure's backbone network. Keeping traffic on the Azure backbone network allows you to continue auditing and monitoring outbound internet traffic from your virtual networks. Simple to set up. Service endpoints are simple to set up with less management overhead. You no longer have to reserve a public IP address in your virtual network to secure Azure resources through IP firewall. There are no NATs involved or any gateway devices required to set up the service endpoints. Service endpoints are configured through a simple click on a subnet, so there is no additional overhead to maintain the endpoints. In the next video, let's look at the various Azure service offerings that support service endpoint services. Now let's run through a lab on Azure Service Endpoints. To demonstrate this, I've created a PaaS offering from Azure, specifically storage accounts is created, and the storage account name is new RGS. I've also created a VNet here, and inside this VNet I have a subnet called corp. The CIDR block of this corp subnet is 172.30.40.0/24. In this lab with service endpoints, what we should demonstrate and understand is the usage of service endpoints. Now, what I will do is try to access this storage account using Azure Storage Explorer. And as we know that Azure Storage Explorer is another tool from Microsoft that will let us connect to Azure storage accounts.
First, to connect to an Azure Storage Explorer, I'll go ahead and create access keys. I'll click on access keys right here and then use this key 1. Just copy this key 1 for now, right like that, and then navigate to the storage account and then click on this icon that looks like a plug. Click on that. There you go. And then use a connection string. My connection string is something like that. Well, missing key. So there's something missing here. Probably my clipboard is not right. So I'll go back to my storage account here, copying this connection string. Yeah, I should have used the connection string as the name itself says. Click next and copy that. There you go. It automatically picked up the storage account name. Let's click next and say connect. Okay, now that we are connected to our storage account, let's expand this and try to create a container inside the blob. I will right click on the blob container, create a new blob and say finance data. Okay, and let it go. Looks like there's some message here. What does it mean? Containers may contain lowercase, of course. So I have this F in uppercase, so I'll put that in lowercase. Good. So do I have a container? Yes. So of course you can go ahead and upload content here, but the purpose is to restrict the data access from a particular network, right? So at this point I have access from the internet. There are no modifications that we have done as far as service endpoints are concerned. Now let's go back to the storage account and do certain modifications in the service endpoints, in the virtual network, and also in the firewall section right here. First thing that I'm going to do is go to the networks here, click on the subnets, drill down further, and then if you scroll down further, you will see an option called service endpoints. The service endpoint that we're dealing with is a storage account. So out of these past services, I will select Azure Storage and then save it. So we are saying that Azure Storage account will be accessible from the following subnet. I will also do the change inside the Azure Storage account. For that, I will navigate to the storage account, click on Firewalls and Virtual Networks, then select my specific network. The network which I'm interested in is VNet-Corp. That's what we created. And the access must be restricted from a subnet called Corp, right? So I'll go back here and then save it. Now, based on this configuration at the VNet and at the security group level, based on this configuration at the VNet and also at the storage account level, we have restricted the communication between these two. So now the virtual machines that are hosted inside the subnet called Corp will be able to access the data inside the storage account. Now what will happen to the Azure Storage Explorer? Now I have created the finance data container from the internet. So I connected the Azure Storage Explorer and then the storage account was connected. As you can see, new RGS is right here. But then would I be able to do anything further from here right now? Well, ideally I should not be able to do because the communication is restricted between the VNet and the storage account. But this Storage Explorer is open from my laptop, which is from the internet. So let's try to create another container here and then name it as hello or something. Say OK. And there you go. You got an error message that the request is not authorized to perform this operation. And that is only because we have service endpoints established. I'll go back to the storage account and try to see if I can access or create new containers from here. Well, although I see finance data, will I be able to access it? Let's see. I'll click on it. Mostly I should get an error message. There you go. You do not have access because there have been changes to firewall and virtual networks. So as we saw that the communication between the virtual network and the storage account, which is a PaaS service, has been established here, and this is a security filter. You can also do similar operations for Azure SQL, Azure Warehouses, and other platform as service offerings. It is easy to add a service endpoint to a virtual network.
There are several services that Azure offers and they are compatible with service endpoint services. Azure Storage. Now, Azure Storage is generally available in all Azure regions. This endpoint gives traffic an optimal route to the Azure Storage Service. Each storage account will support up to 100 virtual network rules. Azure SQL Database and Azure SQL Data Warehouse also support service endpoints. Azure Database for Postgres SQL and MySQL are available in all regions where database service is available. Virtual network services, endpoints, and rules extend the private address space of your VNet to your Azure database for PostgreSQL Server or MySQL Server. These are platform as a service services available from Azure side. Cosmos DB is available in all Azure regions, and you can configure the Azure Cosmos account to allow access only from a specific subnet of your VNet. By enabling service endpoints to access Azure Cosmos DB on the subnet, the traffic from that subnet is sent to Cosmos DB with the identity of the subnet and virtual network. Once the Cosmos DB service endpoint is enabled, you can limit access to the subnet by adding it to your Cosmos account. Azure Key Vault. The virtual network service endpoints for the Key Vault allows you to restrict access to a specific virtual network. The endpoints also allow you to restrict access to the list of IPv4 address ranges. Any user connecting to your Key Vault from outside these sources is denied access. Other services like Azure Service Bus and Azure Event Hubs, although available in all Azure regions, the integration of Service Bus with VNet service endpoints will enable secure access to messaging capabilities from workloads like virtual machines. Azure Data Lake. These are also available in all Azure regions. This feature will help you secure your data lake storage account from external threats. Adding service endpoints can take up to 15 minutes to complete. Each service endpoint integration has its own Azure documentation page, which will be worth looking at when you are implementing a service endpoint for a particular PaaS offering from Azure. By default, when you create an Azure subscription, an Azure AD domain is created for you. This instance of the domain has an initial domain name in the form of domain name.onmicrosoft.com. So the .onmicrosoft.com will always be the suffix for your domain. This initial domain name will be fully functional till the time you have your custom domain name verified. Custom domain name can be your company name or your organization name. Although the initial domain name for a directory cannot be changed or deleted, you can add any routable custom domain that you control. I will navigate to the Azure console here to show you how the custom domain name looks like. Now on the top right hand side, you will see the user ID that you're logged on with. Now, if you just hover your mouse on top of your credentials or the user ID, you will see certain attributes. The last attribute is the domain. If you notice, the domain name is nothing but email address without any special characters, followed by the dot on Microsoft.com. Like I said, this would always be your suffix. You can add your custom domains by going to Azure Active Directory, and then if you scroll down to the bottom a little bit, you will see something called custom domain names. Here, you can add your own company's registered domain name here. Let's say you work for www.alphabeta.com, right? And then you can just add domain. Now, the most important thing is to go ahead and verify if this domain name is really owned by you. So if you own it, you need to log into the registrar of alphabeta.com and create a text record or an MX record. And once that is created, after some time, you just have to click on the verify button. If this is validated, that means that you really own this domain. Till that point, it will stay as unverified because you haven't proved to Microsoft that you really own this domain. This is nothing but custom domain. But what you get initially when you create a subscription is the domain that starts with your email address without any special characters followed by onmicrosoft.com. Azure DNS is a hosting service for DNS domains that provide name resolution. You cannot use Azure DNS to buy a domain name. For an annual fee, you can buy a domain name by using app service domains or a third-party domain registrar. Once you own the domain, you can then manage the DNS records of your domain in Azure DNS. These records created in such DNS zones can be resolved from public or external world. Let's go ahead and create a DNS zone in Azure. So here I am in the Azure portal. Let's go ahead and create a DNS zone. To create a DNS zone, I will just type DNS here in the search box, and what will populate here is DNS zones and private DNS zones. We will talk about private DNS zones later because the idea is to just focus on external DNS zones. So I'll click on DNS zones to create an externally facing DNS zone. Let's click on this add button, and now we are ready to fill up and select these fields. I'll select the resource group as lab. Subscription will be pay as you go. The name here would be the name of the external DNS zone. Mostly this will be name of your company. So if you're registered with your company name with your registrar, then that's what you gotta type here. Let's say your company name is some fictitious company called alphabeta.com. The resource group location cannot be specified because this will be global resource. I'll click on next to select the tags. You can specify the tags so that you can point it to a business unit or a cost center. I'll click on next to review the settings and then click on create. That's how simple it is to create a DNS zone. The records that are created inside the DNS zone are called as record sets. So now we have to go and create a record set. Record sets are nothing but a set of records which we know as an A record, a PTR record, an alias MX record. Well, that's nothing but a record set. So I'll go back to home and see if my DNS zone is created. Looks like it's not, so I'll just refresh it. There you go, the zone is created. So now I can click on my zone, and then what you will notice is the two records that are always created every time you create a zone, NS record and SOA record. From your on-premise infrastructure experience, and if you have worked on DNS, you know that the first two records that are created when you first create a zone is an NS record and an SOA record. Now I will click on the record set to create, let's say, a www record, and it is an A record. Now I can just type in the IP address which I want to point it to. So let's say if you have a public IP of your web server, which is, let's say, 25.63.98.63, right? So this is the IP address of my web server or my load balancer. This is just a fictitious IP which I have typed here, but in your case, you need to pick up the IP address of your web server, or how the routing will happen to the web server needs to be identified and figured out from the network team. So if I click on OK, I will then have a www record pointing it to the IP as a type there. So if I go to www.alphabeta.com, I should be routed to 25.63.98.63, which will be then the IP address of my public facing web server. Now keep in mind, all of this is fictitious because I haven't purchased alphabeta.com. This is just a fictitious name that I've typed here for illustration purposes. But in production environments, this alphabeta will be replaced by your domain name, and then the records will be populated here. And then you will have www record, a mail record which will be mail.alphabeta.com to access your emails, etc. In the next video, let's go ahead and see how you can create a private zone.
When you create a DNS zone in Azure, you will notice that Azure has assigned certain name servers to your zone. Those name servers is something that you can see on the top right hand side here. The easiest way to see the name servers assigned to your zone is through the Azure portal. In this example, you will see that the name server is NS1, 2, 3, and 4. They usually have a suffix of dns.com, dns.net, dns.org, or dns.info. Now, these have been randomly assigned to your Azure DNS zone. You can also discover the NS records with a PowerShell. So you can use get-azure rm DNS zone and get-azure rm DNS record set commandlets to retrieve the zone information. Once the DNS zone is created and you have the name servers, you need to update the parent domain. Parent domain is where your domain is registered. For example, alphabeta.com may not be always registered with Microsoft. It is probably registered with GoDaddy or BigRock or HostGator. There are several registrars as on today. So you need to log into your registrar and use their DNS management system to update these NS records. So in the DNS management page of your registrar, you will edit the NS records and replace the NS records with the ones Azure DNS has created for you. When delegating a domain to Azure DNS, you must use the name servers provided by Azure DNS. You should always use all 4 name servers, regardless of the name of your domain. So far, we spoke about public DNS zones. Let's also talk about the importance of private zones. Let's understand them with scenarios. The first scenario is where you have a virtual network in Azure, and there are a number of Azure resources inside that. And those resources include virtual machines, SQL databases maybe, and you want to resolve the resources from within the virtual network via a specific DNS zone, and you need the name resolution to be private, and this should not be accessible from the internet. Now that's a requirement. Furthermore, for the VMs within the VNet, you need Azure to automatically register them into the DNS zone every time they are provisioned. Now in this scenario, the VNet 1 contains 2 VMs, VM1 and VM2. Each of these virtual machines have private IPs. So if you create a private zone called, let's say, contoso.com, which is what Microsoft calls as a fictitious company. So you create a private zone named contoso.com and link this virtual network as a registration virtual network. Azure DNS will automatically create 2 A records in this zone. Now DNS queries from VM1 to resolve vm2.contoso.com. This will receive a DNS response that contains the private IP of the VM2. Furthermore, a reverse DNS query, which is a PTR, for the private IP of the VM1, which is 10.0.0.1, issued from V2, will receive a DNS response that contains the FQDN of the virtual machine is expected. So we are referring to the DNS, internal DNS. The name resolution of your internal resources within Azure can be done with the help of private zones. Let's talk about another scenario in the next video. The second scenario is where you would need name resolution across multiple virtual networks. And this is probably the most common usage for DNS private zones. The picture that you see here is a simple version of this scenario where there are only 2 virtual networks, VNet 1 and VNet 2. VNet 1 is designated as a registration virtual network, and VNet 2 is designated as a resolution virtual network. The intent is for both virtual networks to share a common zone. The resolution and registration virtual networks are linked to the zone. DNS records for the registration VNet VMs are automatically created, and you can manually add DNS records for virtual machines in the resolution virtual network.
With this setup, you will observe that the behavior for forward and reverse DNS queries will change. The first behavior that you will notice is that the DNS queries across the virtual networks are resolved. So a DNS query from a virtual machine in the resolution VNet for a VM in the registration VNet will receive a DNS response containing the private IP of the VM. You will also notice that the reverse DNS queries are scoped to the same virtual network. A reverse DNS query from a VM in the resolution virtual network for a VM in the registration VNet will receive a DNS response containing the FQDN of the VM. But a reverse query from a VM in the resolution VNet for a VM in the same VNet will receive an NX domain. This is also called as a split horizon functionality. In the next demonstration, let's take a look at the DNS name resolution lab. Let's get started with the lab of connecting the two virtual networks, VNet 1 and VNet 2, with the private DNS zone. So what I have already on the screen is the two virtual networks, which is VNet 1 and VNet 2, and I would like to see their setter block, which is their network ID, which is visible only if I edit columns and then add this address space, which will do it right away. And then you should be able to see the two setter blocks right there. Okay, and we want to connect both of them with a DNS zone so that we can resolve the names and IP addresses. Basically, forward lookup and reverse lookup must be doable with the private DNS. Now I will launch another Azure portal and then search for DNS. One of the entries that you will see in the list is a private DNS zone. I'll click on that and then create a new private DNS zone. As always, we'll fill up this form, select the resource group, and then give it a name. Usually this will be your internal DNS, so I'll just call it as cloud.internal.com or something. And then if there are any tags required for your organization, fill that up, and finally review and create the zone. It should not take more than 2 minutes to create a zone. I'll pause the video and connect back again. Okay, so the zone is created. I'll just click on go to resource, and then you will see that the SOA record is created. But then you can go ahead and connect the virtual networks by clicking on the virtual network links button. Let's add them one by one. Click on this add button and I'll say DNS1, connecting it to my VNet 1. And this checkbox here is important if you want to have your virtual machines in your virtual network 1 to be automatically registered in the DNS zone. So their A record and the PTR record of the virtual machines are automatically created in this zone if this checkbox is enabled. Let's click on OK. Then I will do the second link as well by clicking on the add button, say new to, and then scroll down, select VNet 2 and check that box as well. This checkbox here really makes the life of an admin easier because we do not have to create the A records and PTR records manually. Okay, so now that we have added the two links, once the link is established, we should be able to have the connectivity between the virtual machines in VNet 1 with the virtual machines in VNet 2. So they will be able to resolve each other by names and also by IP addresses. Basically, forward lookup and reverse lookup is something that will work internally within the DNS domain and within the VNets. So that way there's no external access and you will not be able to access the resources using name or IP from the external world. This is purely for internal name resolution with name and IP address. In the beginning of this module, we learned about virtual networks, and by this time we understand that virtual networks are the cornerstone of Azure networking model.
VNets provide isolation and protection of your virtual machines and PaaS offerings like databases. But how do you protect your virtual machines and databases in the VNet? How do we deny certain communication on certain ports and protocols to the resources in the VNet? Network security group is the answer. Network security groups will let you control the inbound and outbound traffic from and to your resources in your VNet. You can allow and deny specific port level communication. In the next video, let's learn more about network security groups, and specifically we'll be discussing about the scope of network security groups. A virtual network is the outermost boundary of your network. Inside the VNet would reside a subnet or multiple subnets. And then inside the subnet would reside your resources like your virtual machine or databases. Now this looks like a layered model. The network security groups can then be linked to subnets or the network card of your resources or both. Binding network security groups to your individual virtual machines by network card is considered very powerful. But also you may lose track of them because as and when you deploy new resources, it will be difficult to track and maintain the security groups and the rules associated in it. It is recommended to link a network security group at a subnet level and reuse across virtual networks and subnets. Be very careful when you want to apply network security groups to both virtual machines and subnet level at the same time. Network security groups are evaluated independently and allow rule must exist at both levels, otherwise traffic will not be admitted. Let me explain this to you by giving an example of the incoming traffic on, let's say, port number 80. You need to have network security group at the subnet level with the allow rule for port number 80, and you also need another network security group with allow rule on port number 80 at the NIC level. For incoming traffic, network security group set at the subnet level is evaluated first. Then the network security group set at the NIC level is evaluated. For outgoing traffic, it is obviously the reverse. The picture that you see here should even clarify this concept even more. So you can see how rules are evaluated for network packets. And once again, remember that you need to evaluate this diagram two times. One for the subnet level NSG rules, and then once for the network card level NSG rules. That the security rules in the security group enables you to filter the type of network traffic that can flow in and out of your virtual network subnets and the network interfaces. When you create a resource like a virtual machine, there are certain default security rules that are created, and they are categorized as inbound and outbound security rules. So there are three default inbound security rules. The rules deny all inbound traffic except from the virtual network and from Azure load balancers. There are three outbound security rules. The rules only allow outbound traffic to the internet and the virtual network. It is easy to add more inbound and outbound rules. So there is a basic and advanced page. The advanced page option lets you select from a large variety of services such as HTTPS, RDP, FTP, and DNS. Let's talk more about it by launching the Azure portal and looking at these inbound rules and see how you can add a rule there. Alright, here's my Azure portal and I will type network security groups in the search box. You will see two options here at least. Other one is classic, which we don't want to get into because that is an older method of managing security groups. This will be deprecated. So the one that we'll be focusing on is the network security groups. So we'll click on it and then you can either click on this add button or click on this blue button which says create new security group. Go through the regular options, subscription, select your resource group, and then I will create a security group with the name allow 80. So I want to allow port number 80, and then you can select the region in which you want to host this network security group. So mostly this will be hosted in the same region where your resources are. Keep in mind that you cannot link resources with the security groups in two different regions. So if your security group is in, let's say, East US, and your virtual machines are in West US, you cannot link them together. They must be in the same region. For demonstration purposes, I will select East US, tag them, review, and then finally create them. It takes less than a minute to show the network security groups on the screen. So my network security group called Allow AT is now created. Let's click on it and look into the options we have here. As we discussed earlier, we have the two security rules called inbound and outbound, and there are three rules in each one of them. As you see, there's a deny rule right here which has a priority of 65500. The lowest priority always wins. So let's say we have two rules with the same port number, 80 in this case, let's say, and they have certain priority. One of them says allow and another one says deny. Which one will win? Well, the one with the lowest number always wins. So if there is any conflicting rule in the inbound security rules or the outbound security rules, the number in the priority is looked at, and the one with the lowest number always wins. You can add the network security rules by clicking on the settings and then inbound security rules, and then click on add to add the source, port ranges, destination port ranges, protocols, and the action that you may want to take. You can also add the priority here and the name of your network security rule. You can click on the advanced version. Just by clicking on basic and advanced, you will toggle between basic and advanced. The service. The service specifies the destination protocol and port range for this rule. So you can choose between the predefined services like HTTPS and SSH. When you select a service, the port range is automatically completed. So you can choose the custom to provide your own port range. So if you select custom, you can specify your own port range here. Otherwise, if you select any of the predefined ones, the port number is automatically populated. As you see in this case, I have selected SSH and the port number for SSH is automatically populated. Let's select custom, and then the port ranges option is automatically enabled. So you can specify and choose a custom service than specifying a single port. Or you can also specify a custom port range, let's say 80, or you have an application requirement where you want to specify 1024 to, let's say, 60,000 dynamic ports, right? The next option here is the priority. We just spoke about it. So this is the order in which the rules are processed. The lower the number, the higher the priority. We recommend leaving gaps between rules. So do not give consequent numbers like 100, 101, 102. The practice is to have gaps between the rule numbers like 100 or then maybe 200 here. The next one will be 300. This is so it is easier to add new rules without editing existing rules. So I will close this option here and discard this and show you the option where you can attach this particular network security group to either a subnet or a network interface. On the left hand side, if you click on the network interface option, you will have the option to associate with a network card. At this point, I do not have any virtual machines or network cards in East US, but I do have subnets. So if you click on subnets, you will have the option to associate it with a subnet in your particular region, right? So just by clicking OK, I'm associating all the rules in the security group with the default subnet in my virtual network called new underscore vnet2. By doing so, all the virtual machines and resources in that subnet will have this rule applied. In this lab, we learned how to create a network security group, edit the security rules, and then also associate with either a network interface or a subnet.